continuing with our examples from yesterday, this is a kind of a thought experiment. So consider this scenario. A friend hands you a coin and tells you this coin is biased towards landing on heads. It's a what they used to call a loaded coin.
Heavy.
Right? It's heavier on one side. So if you got 3 heads in a row, would that be enough to convince you that the coin was really biased?
No.
And pretty much everyone says that. They're like, yeah, 3 in a row, that could happen. What if you got 7 heads out of 10? So you flipped it 10 times, and 7 times it was heads.
No.
I could probably do that.
Is that enough to convince you that the coin is rigged?
No. Maybe you're just throwing it wrong.
No, but is it getting kind of close to it?
Yeah.
You
It's all about how high you flip it and what you start on. I'm dead serious. You start on heads, you flip with the same height, it'll land on either head or tails every time. I've practiced it, Mr. Davis. Do you have a coin?
Let's test this theory out.
not right now, but
Alright, good, because it might not work. But it's worked before. I'm just sitting around like it's tossing a coin. I'm like, oh, I started on this one. Same thing.
I can do a trick where I put a quarter in my hand and it's heads up,
Yeah.
and I do this, and I ask you which is it going to be, and you say it's tails, and I can make it be heads.
Do it.
I don't have a
I have
coin.
one.
I'm sure I can find a coin in here.
I have a coin, I think.
It works best if it's something large like a quarter.
Okay.
Dimes are harder to do.
I got a nickel.
Oh no, coins aren't in here.
Nickel should work.
Oh no, I got a quarter for you.
You got a quarter?
Yes.
All right. So
Oh, dropped it.
And then after you have to tell us how you did it.
the quarter is heads up, right?
Wait, I didn't see.
Quarter is in the palm of my hand.
It is heads up.
Heads up. All right. So which is it?
Should be
Tails.
tails.
It's tails, right? Now what is it?
Tails. Heads.
It's still heads.
Why?
Wait, do it again. Do it again.
It's head.
Let me see.
All right,
I
it's
think he
heads,
does
right?
that. Like as he does it, he like flips it
Tails.
in his hand.
What? Wait, do it. Wait, one more time. You're flipping it before. Let me try.
No. It's heads.
Yeah.
It's heads, right?
Yeah.
What is it?
Head. What? That's crazy. Wait, do it.
Wait, was it tails
Do
or
it
something?
again.
So it's heads,
Yeah.
right? Which is it?
I know it's heads.
It's tails.
Oh.
It's heads.
Uh-huh.
What is it now?
What the?
Whoa, wait, Mr. Davis.
Let me see it. Let me see the coin.
So what you actually do is, and I'm messing with you because I know what you're thinking. I know which one you're thinking it is before I ask you. But so you can just flip it,
Mhm.
but you can also turn your hand out from underneath it and cover it. It's really easy if you set it on the edge. You're just doing that. You're pulling your hand out from underneath it and letting it fall straight down.
Oh, let me see.
I saw you guys in the hair
But
the
then
first time.
it
That's
just
why I
goes
kept saying, do it again, do it again.
That's when it goes to heads again, right?
Right. So now it's still heads.
Uh-huh.
So what I'm doing is I'm actually rotating my hand out from underneath
So it
it.
just falls, not that it flips.
Correct.
I noticed something the first time. That's why I kept saying, do it again, because I wanted to see if you could do it.
But the trick is to when you flip it, make it sound exactly the same as when you're turning your hand out from underneath it.
Nope, heads. Ha, gotcha. Wait, let's see if I can get past it again. Oh, dang it. I know
It's heads.
This is so obvious, though. It looks.
Right. It's easiest if it's further to the so
Oh, did you see it?
putting it in the middle of your palm and doing it is much harder. You have to be able to move your hand out from underneath it quickly. All right.
Oh, it was.
So, let's say we flip the coin 100 times now. So we're actually doing a fair flip of the coin. Which of the following would convince you that the coin really is biased? And let's do them in order. So if it was 54 heads,
No.
Would that convince you?
Nah.
How about 60?
No.
How about 70?
No.
80?
Yes.
I
Yeah.
mean, I'd be very.
80, I would be like, wow.
You'd be highly suspicious. What about 95?
Oh,
It's definitely biased. The thing does not have a tails.
For me on this one, I'm pretty convinced it's 70 actually.
Why?
Why would that be?
Well, okay, let's say we did it 1,000 times. Okay? If 700 out of the 1,000 were heads, do you find that convincing?
Yeah.
But the interesting thing is, it's the same percentage.
Yeah.
Yeah. It's the same with 7 out of 10.
It's the same as 7 out of 10, and almost no one's convinced with 7 out of 10.
Yeah.
That's cool.
And you're like, well, why is that? It's because if you do this experiment enough times, it should be moving closer and closer to the theoretical probability. So if you did it 10,000 times and you got 6,000 heads, you're like, okay, that's hinky. Right? Now, everyone has their own sort of personal feel for this, but everyone has this sort of breaking point where they're like, yeah, I don't buy it anymore. And that's what they call personal probability. We don't actually get into that because it's all subjective.
That's why it's not on the AP test.
Yeah, that's not going to be on the AP exam. So, let's look at simulating tossing a fair coin 100 times on a calculator. So grab your calculators. So our component is tossing the coin, and the way we do that is with a random integer, either 0 or 1. 0 is going to stand for tails, 1's going to stand for heads. Right? You can do that with a random integer. You guys all know how to do this at this point, yes?
Yes, sir.
On whichever calculator you're using.
You put it on random or radiant? It's radiant, right?
Pardon?
Like, when we go to probability,
Yes?
you go random, do you say random up here, or do you say radiant?
Radiant.
That's random integer, man.
Radiant? Oh.
Random integer, yes. We want to do a random integer between 0 and 1.
What'd you get first?
1.
Yeah, tails. 0. Oh, wait, no.
That means I would have won the volleyball coin flip. Because I always pick heads.
Okay? So, but that's just one component. If we wanted to do this 100 times, that would, I mean, you could do it. It would be awful, but you could do it. It's time consuming. Okay? So, if instead of doing one at a time, you can also do random integer, tell it to go between 0 and 1, and tell it to do it 5 times. Right? Is everybody good with making it do it 5 times?
Yes. Oh, wait, it says undefined.
Times 5.
No.
I just got heads 4 times in a row.
Go to the next one down.
Wait, why is mine?
Hang on. Set random integer, no repeats. That's not what we want.
Oh.
Kill all of that. Kill it with fire. All right. So.
Stan, where'd you go?
Wait, go to the restart. That one.
When we just did up here. So 0.
1. You just press enter.
Oh.
I know, but I need to do
There's
it
got to be
sometimes.
another way to do
Press
that.
enter.
No, but it's supposed to do it to where
Hmm.
you get a 5. You do it 5.
Well,
Hold on, let me
so
see.
did you?
Oh.
Did you get to get?
Well, I did random no repeats, so I guess I just have to.
So the problem is you can't do random no repeats.
Yeah.
So I think I need to
You just
get.
have to press it 5 times. That's what I
But
did.
that's what he was trying to get us to not have to do, right?
Yeah.
Yeah.
And I'm sorry. I thought that on the numworks there was one where you didn't have to do that, but hang on just a second.
syntax error when I try to put a comma on stuff.
Yeah, it won't let you do that.
Dang it, man.
I know, I'm sorry.
Okay, you can do that. However you do.
I was really good for forgiveness.
I know, you always are. Just always doing stuff, right? You're good.
What? You got me right.
I didn't know volleyball did a coin toss.
Seriously? How did you think the determined two got served?
Oh, right.
I'll have to see if I can figure out how to make that do. I just don't know.
How did mine have the little thing? The extra one.
On the TI, it's actually pretty easy. You just
I don't know probability, you know what I mean?
tell it how many you want, right?
Dude, it is
Yeah.
probability. Is it probability? Really?
Probability.
What's the matter?
Mine doesn't have the
So look, you
random
got
integer.
probability. Random.
Mine doesn't have that.
Oh, you probably didn't update it or something.
Oh, shucks. Like, look, if you get probability,
Uh-huh.
then random. Mine doesn't have the one where you can put a column. Oh, darn it.
No repeats.
Did you ever plug yours in when you first got it to update it?
Is this why it always does this?
Update available? Yes. And how would it
Well-
know that there was an update available if it doesn't actually connect to the internet unless you never updated it?
Yeah, I don't know. I was just assuming that they would give it to me the right way. You need to talk to your guy about that.
About the updates?
They want you to update it when you first get it, so you get whatever is the most recent one, and they don't have to worry about their inventory because they update at least once a year.
You gonna talk to your guy about this, Mr. Davis?
If I can't figure it out on my own, yes. So you could do this, 100 times and keep track of it. You could have it, give 100 random numbers between 0 and 1. But if you wanted to know how many heads that was, you'd have to keep track, right? You'd have to go through and count them all. Or the other thing you could do is and I don't know where this is on the
Numworks.
Numworks.
Darn, we should have stuck with our TI.
Shh,
No.
you're so funny.
I love my numworks, Mr. Davis. I love it so much. It's literally the best calculator in the world.
This thing was still. Don't say it's because I'm fast.
You already know it.
I'm gonna have to find it. So I did this for the TI for last year. You can have it sum, and if you added all those numbers together, well, 0 represents tails
Yeah.
and 1 represents heads. You could just go, what's the sum of all those? And
Here's the number of heads.
right.
And you can figure out.
That's
the number of
genius. How do you figure this stuff out?
tails. That was very smart, Mr. Davis.
That's not all that.
I would have never thought about that. I would have just
I
counted.
just asked you,
So-
Mr. Davis, how do I know?
So computer science was my first major. I didn't stay with it for very long, but I know how to do basic programming.
Like Jake McCaffrey can get me through any paywall.
Excuse me?
Is that not the same thing? Like hacking and stuff?
No, hacking is a different skill.
That's the
Oh.
illegal kind of skill.
Well, he can hack websites and get me into paywalls. Get me through them.
Okay.
In case you need to get to New York Times, Jake's got you. It's actually really cool how he does it.
Really?
It like brings up this whole sheet like in green, with like random words, and then he gets me through somehow. And I don't have to pay.
The New York Times?
Yeah, or Wall Street or whatever. That's how I use it for debate.
All right. So here's a question for you before we get back to what we've been doing. If you were to run our simulation, but with 10,000 coin tosses instead of 100, so you're tossing it a whole bunch, do you think we would see more variability or less variability in terms of the percentage that the coin showed heads?
On a regular coin.
Less variability.
On our simulation.
So the weighted coin.
So the weight.
So if we flip it 10 times, we're not surprised if we get 8. Maybe a little surprised. We're not surprised if we get it 7, right?
One makes a difference.
Yeah, but it kind of does, right? You feel that. So if we got 70%, we wouldn't be all that surprised. If we ran this 10,000 times and we got 7,000 heads, are we surprised?
Yes.
We're very surprised. So the more you do, the more simulations the more trials you run,
Well, less variable.
More variable.
you have less variability. Because it's not going to go all the way up to 70%, is it?
No, it shouldn't. If it does, then something's wrong with your.
Oh, yeah, so that makes, okay.
You're going to have a smaller standard deviation.
I get it.
It's going to be more tightly packed around 50%.
Right, because you said the bigger it gets, the closer it gets to the predicted.
Theoretical.
The theoretical probability.
Yeah.
Wait, are we thinking like the regular coin or just the weighted coin?
We're not talking about either of those. We're talking about our simulation. Our simulation will show less variability in terms of percentage, a smaller standard deviation, if we do this 10,000 times than if we do it 10 times.
Yes, that makes sense.
Okay? All right, so let's look at some of these. By the way, that's something that we'll study later. It's called the central limit theorem, where if you do this over and over again, you tend to hone in on the theoretical probability. All right, suppose a basketball player has an 80% free throw success rate. Design a random number simulation to find the number of free throws we might expect for them to make in a row. So the component is going to be shooting a free throw. How are we going to simulate that?
0 through 7 is something, is making it, and 8 through 9 is missing.
Okay, we could do it that way. There's more than one right way to do it, but yeah. So randomly generate an integer from 0 to 9. Or you could do 1 to 10. It's fine. Either way doesn't really matter. Let 0 through 7 represent a make. And 8 through 9 represent a miss. What is our trial going to be on this?
Randomly generate numbers.
Or we've already randomly generated the numbers. We've done a component. So what are we going to do? You have to read the question carefully.
We're gonna do a trial.
We're gonna do a trial to see how many he can make in a row.
Okay,
Good
so
job.
If-
Trying to start reading the problems, Mr. Davis, like you're saying.
yeah, you really do have to read the problems. So a trial will repeat the component until there is a miss.
And how many trials should we do?
Well, hang on just a second.
Oh.
We're not talking about how many trials we're doing. We're just doing a trial.
Oh, just one.
Because we're just seeing how far he can go until he misses.
We're gonna,
okay.
and we're going to count the number of makes. Okay, the response variable would be the number of free throws made in a row. Out of that, we hope to get a statistic. What would we probably do with this? If we ran this trial multiple times,
Average them.
we probably would average them.
Oh, so we would run it multiple times.
Yes. Right, but we weren't there yet. We were still in the single trial.
Okay.
So probably the average number of free throws made in a row. All right, let's look at another one. We're going to use a basketball player who has a 72 success rate on free throws. You're like, okay, this sounds a lot like the other one. Design a random number simulation to find the number of shots they might make out of 5 chances at the end of a game. So the component is going to be what? Shooting the free throw. So we're going to generate random integers. And for this one, I'm going to do it from 1 to 100.
Since it's not like an even 10, 20, 30.
Yeah.
Yeah.
You could do 0 to 9, but then that's really difficult because then it's like, what are you going to do with the 72%? Let 1 to 72 represent a make. And 73 to 100 represent a miss. Now, to your question, could we have done 0 to 71 and 71 to 99? Absolutely. Okay, and if you were using a chart of random digits, a table of random digits, that's the way you would want to do it. Right, because you always want to be looking for a 2-digit number. Okay, so what is a trial going to be on this?
You're gonna try it 5 times.
So repeat the component 5 times.
And see how many you make.
And what are we going to get out of that?
See how many you make for free throws.
Right? Count the number of makes. So the response variable is the number of makes out of 5 tries. Do you see how that's different than the previous one?
Yes.
And then the statistic would probably be the average. The average number of makes out of 5 tries. Here's where it gets really interesting. How would our trial response variable and statistic change if we want to know our player's chances of hitting both shots?
How would our trial results variable and statistic change if we want to know our player's chances of hitting both shots when we go?
So our trial would be to repeat the component twice. Or do the component 2 times. right, then record whether they made both, whether they were both makes or not. And that's a trial. The trial is just the component twice. So they're going to shoot 2 free throws. So you're going to repeat the component shooting the free throw twice. And you're going to record, did they make them both or did they not make them both? And your response variable would be then, did they make them both or not make them both? And we would record probably, on average, how many times do they make them both? All right?
So that one kind of just combining both, like, 4 and 5 then?
I'm sorry?
That one's like combining 4 and 5 then?
Kind of.